Okay, in this lesson we're going to be looking at parabolas. I know we talked about parabolas back in chapter 6, but in this lesson we're going to look more at some other details about parabolas that we didn't talk about before. And that's the idea of a focus and a directrix. But let's look at this definition of a parabola. Make sure you get this copied down in your notes if you're copying them down. It says, let L be a line and F be a point not on L. A parabola then is the set of all the points equidistant from the focus F and that line L, which we call the directrix. So the focus is a point and the directrix is going to be a line, and the parabola is going to be a whole bunch of points that are the same distance from that point, the focus, and that line, the directrix. So here's what I mean. Let's say, for example, we have a line like this. This would be the directrix. And then if we create a point, that is the focus. Our parabola then, the vertex of our parabola is going to be halfway between these two, the directrix and the focus. This would be your vertex. And the parabola then would be all the points that are going to be equidistant between the focus and the directrix. For example, I know this isn't a perfectly drawn parabola, but it's kind of close. Let's say if I pick this point here, if this was a perfectly drawn parabola, this distance and this distance would be the same. Or if I pick this point over here, that distance to the directrix and the distance to the focus would be the same. So no matter where you pick a point, the distance from that point to the directrix and the distance from that point to the focus would be the same. That's the definition of a parabola. So the points on the parabola, the points on that line are always going to be the same distance from the fixed point, the focus, and that line called the directrix. And the vertex is going to be halfway between the focus and the directrix there. This just gives us another diagram. It's a little bit more complicated since it's all shown all at once. So it's easier to break it up in pieces like I did for that other one. Okay, so let's look at some examples. Well, before we do that, actually, let's talk about some more about the focus and the directrix. And then we'll get to those other examples. So today we're going to be focusing on just when we have equations in this form, y equals a times x squared. When we have an equation in that form, the focus is going to have the value, or it's going to be the point, where x is 0 and where y is 1 over 4 times whatever a is. So remember, the focus is a coordinates. That's how we would get the coordinate. If I know the equation, if I know my value for a, I could find the focus by putting that value for a in here, and for these particular problems, x is always going to be 0, and your y value, like I said, would be 1 divided by 4a. And the directrix then for this parabola would always be y equals -1, I'll write it like this. -1 over 4a would be the equation for the directrix. When the directrix is a line, so that's why it's going to be in the form y equals, because that's the equation of the line. And the focus is a coordinate, so it's going to be x equals 0 and y is 1 over 4a. Now if you notice, between this 1 over 4a and -1 over 4a, they're the same, only opposites. So let's look at our first example here. If you notice, the focus, the y value for the focus, and our directrix, those are the same number, only opposites. That's going to come in handy in a minute when we do the second example, example number 2. But for this first example, they ask us for the equation of the line. Remember, the equation is going to be in the form y equals ax squared. Well, there's two ways we could go about doing this. We could use the focus, or we could use the directrix. Both of these methods would give you the same answer. So I'm going to show you both ways, and then you can decide for yourself which way you prefer. Personally, I prefer the focus, using the focus. You'll see why here in a minute. Now remember, the focus is the point. Do this in a different color. It's going to be the point where x is 0 and y is 1 over 4a. Now, I know that my focus is the point 0, 2. So in other words, this value 2 is a result of taking 1 divided by 4 times some number. So I want to figure out what that value for a would be that would give me my 2 for my y value. So I know that when a is some number, my value is going to be 2. So I want to set it up as an equation to say 2 is the same as 1 over 4a. And now we just solve this. I'm going to solve this by multiplying both sides by 4a, which gives me 8a equals, well, on the right side, those 4a's cancel out, leaving us with just 1. So I know now that a would equal 1/8. But that's not our answer, really, because the question isn't asking us to find a, it's asking us to find an equation for the parabola. So we go back up here, so your answer would be y equals 1/8 times x squared. That's our goal. Now, like I said, we could use the focus or we could use the directrix. Let's see how we would use the directrix now. Remember, the directrix is found by taking y equals -1 over 4a. Well, we know for this problem, we know that y is equal to -2, so I can substitute that in for y. So instead of y equals, it's going to be -2 equals -1 over 4a. And if I multiply both sides by 4a, 4a's cancel out, and 4a times -2 is -8a equals -1. But when I divide by -8, I get a equals -1 divided by -8 makes a positive 1/8. Which again, if I put that in my equation for y equals ax squared, I'd get y equals 1/8 x squared. So like I mentioned earlier, either one of these methods you can use to come up with the equation of your parabola. Let's look at doing this one on your own. So here they give us a focus of 0, 1 and a directrix of y equals -1. Why don't you take a minute and use either method to come up with the equation in the form y equals ax squared for this parabola. So pause the video and hit play when you're ready to check your answer. Okay, like I said earlier, I prefer using the focus. So again, our equation is going to be in this form. So I know I get that answer for 1 when I take 1 divided by 4 times some magical number a. So we're trying to figure out what a is. So just like before, we're going to multiply both sides by 4a. So those cancel out, so that tells me that a equals 1/4. So my equation then would be y equals 1/4 x squared. And I'm done. So that's how simple it can be. Now what if they give us the equation and we need to come up with the focus and the directrix? That's what this last example does. So let's look at this one. So they give us the equation y equals -1/6 x squared. I know from here that my value for a would be -1/6. And I know my focus is the point where x is 0 and my answer for y is 1 divided by 4 times a. So I'm going to simplify that. So I'm going to put -1/6 in there for a, so it's going to be 1 over 4 times -1/6. Now when I multiply that, remember 4 is the same as 4 over 1, so when we multiply these together, multiply the numerators and the denominators, so it becomes -4/6. But the problem is we cannot have a fraction inside of a fraction. You cannot leave it like this. The only way to get rid of a fraction when it's inside of a fraction is to multiply the numerator and the denominator by the reciprocal, which is -6/4. Because the negatives then would cancel out, the 6's would cancel out, the 4's would cancel out for the denominator. In the numerator, 1 times -6/4 is just -6/4, which reduces to -3/2. And remember what we just found here is I took, and I'm trying to find the y value for my focus, and I just simplified it, so my answer would be -3/2. The directrix then, remember these are opposites of each other. So I know my focus, the y value is negative 3/2, so my directrix would be y equals a positive 3/2. And there's my answer. That should be enough for you to be able to do your assignment. So with that, good luck.